In this video, I'm going to be talking about adding vectors algebraically. So there's three ways that we can add vectors. So the first way is perpendicular vectors. So these are two vectors that come together at a 90-degree angle in order to create a perpendicular triangle. So for this, we'll use Pythagorean theorem, which is c squared equals a squared plus b squared. And then also the trig ratios, specifically the tangent ones. So we use the term SOHCAHTOA just to remember the operations. So for the TOA part, it's tangent of the angle is equal to opposite over adjacent side. Okay, remember, because we're going to be creating a resulting vector, because it's a vector, it must have not only the magnitude, but also direction. So I'm going to be showing you how to determine the direction of our vector. Okay, so in this example, Neil walks 1,500 meters north, then 750 meters west. We're going to find his displacement. So the key aspects here is that our y component is 1,500 meters north. Okay, so in the positive direction, and then our x component is 750 meters west, or in the negative direction. So I'm going to start by drawing my components. So my y is 1,500 meters, okay, to the north, and then for my 750 meters, that's going to be going towards the west. All right, so my resulting vector would be this, because my displacement, remember, is the shortest distance from the starting point to the ending point. And then to find my direction, so this is my displacement. So then to find the direction of my displacement, this would be the angle that I have to solve for in order to describe the direction of my displacement. Okay, so to start, I'm going to use Pythagorean theorem in order to solve for delta D. So remember, it's c squared equals a squared plus b squared. So I'll use my delta D as the c, and then I'll have 750 squared plus 1,500 squared. All right, and then once I do this, make sure, so I'm going to square 750, I'll square 1,500, I'll add those values together, and then I'll take the square root in order to get delta D by itself. So for delta D, I'm going to get 1677.05 meters. Okay, so that's going to be the magnitude of my displacement, but then again, I have to find the direction, so I need to find this angle of theta. So to do that, I'm going to do tangent of theta is equal to opposite, which would be my 750 over adjacent side, which is my 1,500. So 750 meters over 1,500 meters. Okay, so then to get theta by itself, I have to take the inverse tangent of both sides. So I end up with the inverse of tangent of 750 divided by 1,500. All right, and so I get that theta is equal to 26.6 degrees. All right, so now I need to write out what my resulting answer will be. So my total displacement is equal to, okay, looking back at my sig figs, here I have two sig figs because the zeros fall off. There's no decimal holding them on. And then here I have two sig figs as well. So my answer needs to report two sig figs. So here would be my two sig figs. Here would be my two sig figs. So for this one, I need to round it. So instead of 1,677, it'll just be 1,700 because it's going to round up meters. Okay, now for my direction, I know what the angle is, but I need to look at where that angle is in relation to my compass, the north, south, east, west. Okay, so here I have the north compass line. Okay, so off of that, that's where this angle is. So from the north compass line, it drops the 26.6 degrees towards the west. So to write that, I'm going to have from the northern border it's going to be, instead of 26.6, it'll round up to 27 degrees to the west. It's also important to find the vector components. So we can use the other parts of SOHCAHTOA, so the SO and the KA, in order to find those components of the actual vector. So in this example, a helicopter traveling 95 kilometers per hour at an angle of 35 degrees above the horizontal, that's what the ATH means, find the components. Okay, so my vector will look like this, okay? And I know that the angle above my horizontal, so this angle here is going to be 35 degrees, okay? So I want to know what is the x component and what is the y component, okay? So to start, we'll start with the y component. So it's opposite of our angle, so we're going to use SOHCAHTOA or sine in order to solve for that. So sine of my angle 35 degrees is equal to opposite, which is y, over my hypotenuse, which is 95. I'll multiply both sides by 95 in order to get our y side to be 54.48. Okay, so then for my x, because it's the adjacent side, I'm going to use cosine. So cosine of 35 is equal to x over 95. Again, I'm going to multiply both sides by 95 to get x by itself. And then when I solve, I will get x is equal to 77.81. All right, so looking back at my problem to determine my sig figs, I have two sig figs here, okay? And you will notice that in terms of the degrees, they have two sig figs as well. But in terms of this class, we're not going to consider the degree or angle to figure out sig figs, okay? So just kind of ignore those whenever it comes to the number of sig figs and just look at this number here. Okay, so in order to report my final answer, the x component, so I need to round it to 2 sig figs, is going to be 78 kilometers per hour, okay? And it's in the positive direction, or you could put to the right or to the east, okay? Anything would work there. So I'm just going to put the plus sign because we didn't really have a north, south, east, west in this problem. And then for my y component, it's going to be 54 kilometers per hour, okay? And then this one is also in the positive direction, or you could put up or to the north.